Okay, so in our previous example, we looked at a prism. So reminding you, we use the same prism here. Okay, so n equals 1.52. This was a 32-degree angle. It was in air out here. And so light came in here, refracted, and we found that the angle relative to going straight through, in other words, the angle of deviation here, was 1.8 degrees. Okay. All right. So there we have a prism here. Okay. And no, wait, hang on. I got the wrong number right there. That was not 1.8 degrees. Okay, so that was 18 degrees. Okay. All right. So, our next thing we want to look at, though, is what if we had a prism, same prism, and we put it underwater? Okay. So same prism, 1.52, except now out here, this is water. So the index fraction's 1.33. And so light's going to come in here. It's going to refract. It's going to refract again. And so we want to do the same thing. So this is still 32 degrees. So this is still 74 degrees. So that means this angle right here, theta 1, is still 16 degrees. Nothing has changed until we get to theta 2 on the inside here. So we know that n1 sine theta 1 equals n2 sine theta 2. Do a little bit of math there. Theta 2 now comes out to be 14 degrees. So theta 3, same theta 3 that we had before, is now going to be equal to 76 degrees. So theta 4 over here, theta 4 is now going to be 72 degrees. So theta 5 is now going to be 18 degrees. Okay, so n2 sine theta 5 equals n1 sine theta 6. So theta 6 now comes out to be 20.7 degrees. So that's theta 6. So theta 7 here, theta 7 is now 69.3 degrees. Okay, and so here is our 74 degrees. So theta 8, that's our angle of deflection. Remember, before it was 18 degrees. Now it is 4.7 degrees. And so by putting the prism underwater, we have drastically changed the properties of the prism. So we've changed the pattern here. We've changed where the prism would cast its rainbow of colors.